This is part one of our study on polynomial functions and their graphs. And so in part one, we're going to look at these four objectives. So basically, by the end of this lesson, you should be able to have mastered these four items. So the first one is you need to be able to classify polynomials. Secondly, you need to be able to identify characteristics of a polynomial function. Third, you need to explain why a given graph or a function is not a polynomial function. And then four, you need to identify polynomial functions and their degree. Okay, so those are the four things we're going to talk about. Now, before we can do these things, though, we need to understand the definition of a polynomial function. So what does a polynomial function look like? What is the definition? All right, so here's the definition of a polynomial function. Okay, so polynomial functions. All right, polynomial functions. All right, so a polynomial function of, and this is important, degree. So the word degree, so remember in one of our objectives we had the word degree. So a polynomial function of degree n, so you can understand what that means in a little while, is a function of the form. So it has this form, so it looks just like this. Now this is what I'm about to write it as will be a lot of variables and letters, symbols, but we'll look at some examples. But it has this form. So it has a form. I'm going to go ahead and use the notation that your book uses. Your book uses f of x. So it has the form f of x, or any function notation, doesn't matter, but it looks like this. It's a sub n. Now notice I'm reading this as a sub n, sub, S-U-B, a sub n, times x to the n power, plus a sub n minus 1 times x to the n minus 1 power, and then so on, plus a n minus 2, x to the n minus 2, and then so on. So you have a bunch of terms here, and then plus a1 x to the first plus a0. So I ran out of space here, but that's a sub 0. Okay. Now, don't let this notation confuse you. You're gonna notice in a little while what those examples, what all these mean. But notice these are your exponents. So your first exponent is x, the next exponent is x minus 1, the next one is x minus 2, the next one will be x minus 3, and so on. At some point, you're going to have possibly, not always, but possibly x to the first power, and then a sub 0 is your constant. Okay? Now, this is important. So you see all those exponents n minus 1, n minus 2, all of these exponents have to be a non-negative integer. So where n is a non-negative integer. Non-negative integer. And it's important that a sub n, that coefficient here, this coefficient here, it's important that a sub n is not equal to 0. So it could be any other number, any other real number, but zeros. All right, so a couple of things about these symbols that I need for you to understand. Okay, so the first one's this. Let me go ahead and expand this a little bit larger. All right, so these a sub 0, a1, a2, all the way to an, those are called coefficients of the polynomial function, meaning that this right here, a sub n minus 2, a sub n minus 3, and so on, those are called coefficients. Okay, so your coefficients would be a sub n minus 1, a sub n minus 2, and so on, and a sub 1 as well. Okay, so a sub 1. Okay, even this right here, even that constant would be considered a coefficient. Okay, so the numbers in front of the variables are called coefficients, and this constant would be also considered a coefficient. All right, so basically it's like this a sub 0 here would be called the constant coefficient. Constant coefficient. All right, the constant coefficient is spelled coefficient wrong here. C-O-E-F-F-I-C-I-E-N-T. Constant coefficient or constant term. Most of you remember the word constant term. Okay, and the number a sub n, this right here, this right here, this right here, the number a sub n, which is a coefficient of the highest power. So this would be the largest exponent. So the coefficient, so the number a sub n, which is the coefficient of the highest power, is called the leading coefficient. Is the leading coefficient. Okay? And the term, this term right here, a sub n x to the end and a sub n x to the end, is called the leading term. Okay, so a bunch of stuff here, a lot of things being said, but a polynomial function has this form. So you have your variable x is being raised to x, the variables are being raised to exponents. The exponents must be non-negative, meaning non-negative integers, meaning they must be numbers like 3, 5, 7, 6, 22, 23, and so on. Okay, even 1 and even 0. Okay, all right, they cannot be negative 2, negative 5. Okay, so they must be non-negative integers. The numbers in front of the variables are called coefficients. Okay, and then the constant is sometimes called the constant term or constant coefficient. And it's also important that you understand that the term that has the largest exponent, is called the leading term, and this coefficient of the leading term is called the leading coefficient. Okay? All right. So now let's look at some examples of what polynomial functions look like in terms of function notation. Let's look at some examples. So here's some examples of polynomial functions. Okay, so examples of polynomial function. That'll be our first one. So these are polynomial functions. So polynomial functions, and then make sure you understand why what I'm writing is a polynomial function. So polynomial functions. So these are examples. All right, number one. So these are examples of polynomial functions. Okay, so number one. So let's look at this one. So we have g of x is equal to negative 1/3 x to the fourth minus 3x cubed plus 2x squared minus 7x plus 5. So that's an example of a polynomial function. If you look at it, it has this form, right? So the largest exponent, see the largest exponent here is 4. So remember, that's called the leading term. Remember that? That's called the leading term. But make sure you understand that this is a polynomial function because all of the exponents are non-negative integers. So x to the fourth, so that's an integer. That's a positive integer. That's a non-negative integer. Non-negative integer 2. 1 is a non-negative integer, and then your constant 0, your constant 5. Okay, so that's a polynomial function. Notice also that the coefficient in front of the term, the coefficient of the term that has the largest exponent is not 0. All right, so that's what this is saying here. So a sub n a sub n, which is that leading coefficient, cannot be 0. So is it 0? No, it's not 0. It's negative 1/3. So I want to make a note here, make sure you understand, first of all, that the leading term is negative 1/3 x to the fourth. That's your leading term. Okay? The leading coefficient is negative 1/3. Okay, so it's just that number, that factor you're multiplying x to the fourth by. Okay, so that's important. Make sure you understand that information. All right, so we have a polynomial function. So this polynomial function will have a leading term. And remember, the leading term is the term with the largest exponent. So this is 4. That's the largest exponent you see. So that's the leading term. The coefficient is called the leading coefficient. Okay? All right, let's get the next one. Number 2, we have h of x is equal to negative 4x to the fifth plus the square root of 3x to the second power plus 7. All right. Now, I want to just mention this, that you see how number 1 you had an x to the fourth, you had an x to the third, you had an x squared, you had an x to the first, and then you had your constant. That matches right here. That matches this terminology right here. So n minus 1. So for example, see n is 4, right? So 4, what's 4 minus 1? Well, 4 minus 1 is 3. What's 4 minus 2? Well, 4 minus 2 is 2. And then you have your next one, which is 1, and then 0. So this is also, if you look at this is also in descending order. So this is in descending order. So notice that the polynomial g of x is in descending order. All right, so notice you have an x cubed term, you have an x squared term, you have an x to the first term, and you have your constant. Notice, though, the difference between these two is that, do you see an x to the fourth? No, there's no x to the fourth term. Okay, there's no x to the fourth term. There's no x to the third power, right? So you have some missing terms here, but that's okay. All right, so what that means is this. So you see you have no x to the fourth term. You have no x cubed term, right? You have no x to the first power term. Y'all agree? All right, you had all those here. You had 4, 3, 2, 1. Here you don't. You have x to the fifth, but you don't see an x to the fourth. You don't see an x to the third power. You see an x squared. But it's still a polynomial function. All that means is this. I just want you to understand this. What that means is that h of x can also be written like this. Negative 4x to the fifth plus 0x to the fourth plus 0x cubed. So if you have some missing terms, when you have missing terms, that means their coefficients are 0, because 0 times x to the fourth is 0. 0 times x to the third is 0. Okay? So that's going to be important. See that right here that I wrote? That's going to be important in a future section where we have to divide polynomials. All right, so that's going to be important. And then plus the square root of 3x squared plus 0x to the first plus 7. All right? So this makes you understand that that's this. But this is still a polynomial function, even though you are missing some terms. You're missing terms because the coefficients are zeros. Now remember, the definition said that the leading coefficient cannot be 0, right? So which one of these is your leading term? I have 3 terms here. Which one's the leading term? Remember, the leading term is the one with the largest exponent. This is a 5, this is a 2. Hey, let me just go ahead and say this. The constant, remember how I said this is x to the fifth, this is x to the second power. You may say, well, there's no x there. Well, you may remember this. So recall that 7 I can write as 7x to the 0 power, right? Because x to the 0 power is 1. 1 times 7 is 7. So this, if you think about it, that's x to the fifth, x to the second power, x to the 0 power. All right? But we don't put x to the 0. That's just a constant, so we just leave it as 7. Okay, so it's going to be important when we talk about degrees about this idea here. So just remember that 7 I can write as 7 times x to the 0 power since x to the 0 power is equal to 1. And so we get 7 times 1 is 7. Okay? So all these constants, see this right here? That can be written as 5 times x to the 0 power. So note, 5 I can write as 5 times x to the 0 power. Okay? But we don't. We don't put that. We just leave it as 5. All right, so that's important to understand. Okay, so what I want to ask you this is before we go on, is this. What's your leading term? So the leading term in this in h of x, and number 2, is the term with the largest exponent. That's a 5. That's a 2. Your constant has exponent 0 because that's 7 times x to the 0 power. All right, so which one's your leading term? That's this one, right? So your leading term is negative 4 x to the 5th. Your leading coefficient is negative 4. Okay, so your leading coefficient is negative 4. All right, now, one of the other things we talked about is degree in here. See that word degree? So n is the degree of the polynomial. n is the degree of the polynomial. And remember, n is that largest exponent. So the degree of a polynomial function, the degree of a polynomial function, we are talking about polynomial functions here, not just any polynomial functions. The degree of a polynomial function is the largest exponent. Okay? So if I go back and I look at number 1 and I ask you, all right, so first of all, it's a polynomial function, so a polynomial function will have a degree. So the question is this: what is the degree of g of x in number 1? What's the degree of g of x in number 1? So the degree, remember, we just said the degree of a polynomial function is the largest exponent. So which one's the largest? What's the largest exponent here? 4. So the degree is 4. So the degree of g of x in number 1 is 4. Okay, so the answer is 4. What is the degree of h of x in number 2? All right, so what's the answer? So if you look at this, the largest exponent is 5, so the degree is 5. So the answer is 5. Okay? All right. Let's look at the next one. So let's look at another example of a polynomial function. So this is going to be number 3. So here's another example. Okay, number 3. So number 3, we have this one. Number 3. All right. We have k of x equals 5x squared minus 7 plus 0.25x minus 7x cubed. Okay? So that's a polynomial, because if you look at all the exponents are non-negative integers, right? So we have 2, that's non-negative. I'm going to skip this for right now. We have 1, that's non-negative. We have 3, that's non-negative. And our constant, so recall the constant, remember your constant term, I can write, now remember that's negative 7, so be careful, don't say 7, that's negative 7. Your constant term, negative 7, I can write as negative 7 x to the 0. All right, but we don't put x to 0, but you need to know that that's really negative 7 x to the 0. So this exponent is 2, that's non-negative. This exponent is 0, that's non-negative. This exponent is 1, that's non-negative. This exponent is 3, that's non-negative. So it's a polynomial function. It is a polynomial function. It doesn't matter what the coefficient is. The coefficient can be, if you notice, those are integers, those are decimals, which can be rational or irrational, does not matter. All right, it's your exponent that matters. Your exponent must be non-negative integers. Non-negative integers. So I'm going to ask you this now. Now, you've got to be careful. I'm going to ask you, what is the leading term. Now here's where students get confused. When they hear the word leading term, some students think that that means that first term. That's not what that is. The leading term, remember, is not this. The leading term is not 5x squared. Why? Why is the leading term not 5x squared? Because it's not the largest exponent. It's not the term that has the largest exponent. The term that has the largest exponent is this. That's your leading term. So be careful. Your leading term is not always the first term you see. Again, the leading term is not always the first term you see. The leading term is the term with the largest exponent. Okay? All right, so what's the leading term in number 3? Well, the leading term is negative 7x to the third power. Don't say 7x to the third. You got to say negative 7x to the third. The leading coefficient is negative 7. Okay? The degree of k of x is what? Remember the degree? You can take it from your leading term. What's your leading term is this, right? So what's the largest exponent you see? 3. 3, right? So the degree of k of x is 3. Now, I want to say something. What is the difference? Why if you look at number 3 and you look at number 1 and 2, chances are you probably would not have missed this in terms of what's the leading term, because even if you did think the leading term means that first term, you would have still gotten these correct. Why? Because notice that both number 1 and number 2 are in descending order. 4, 3, 2, 1, 0. Your constant term has exponent 0. Number 2, 5, 2, 0. But look, is number 3 in descending order? Nope, it's not in descending order. So I want to say something here, and that's going to be important. Okay, so listen carefully to what I'm about to say. So notice, number 3, in this case k of x, is not in descending order. Okay? So first of all, you have to know that it's not in descending order, but that's okay. You could have still answered these questions. You can still say this is a polynomial function. You can still tell me what the leading term is. You can still tell me what the leading coefficient is. You can still tell me what the degree of the polynomial is. So it doesn't have to be in descending order, but sometimes you will be asked to put in descending order. Okay, so k of x is not in descending order. So sometimes we will be asked to write a polynomial function in, okay, now listen carefully, standard form. Standard form. Now, standard form means descending order. Okay? Standard form means descending order. All right. So you're going to write all these terms. You're going to write them as separate terms in descending order. Okay? So if we go back to number 3, so k of x in descending order would be, so let me go ahead and decrease the size here so I can get that in. So hopefully you can still see this. So k of x, so what will be the first term I would write? Well, if you're going to put in descending order, then your leading term has to be first. So what's your leading term? Right here. So that's your leading term. So you're going to say negative 7x to the cube, x to the third power, and then the next one you're going to say is 5x squared. That's your next one. So 5x squared plus 5x squared. Then x to the first, so 0.025x. And then your constant, minus 7. So that is k of x in descending order. So that's k of x in standard form. Okay? All right, so that's going to be important. At some point, you will be asked to put this in standard form or in descending order. So remember, descending order means the same thing as standard form. Okay, so let's look at number 4. So number 4, we have this. We have h of x equals 8 minus x. All right, so we have this. So 8 minus x. Now remember, 8 minus x is linear, right? So that's a linear function. So notice this is a linear function. So that's a linear function. And it's not in standard form, because notice in standard form we have h of x would equal negative x plus 8, right? So that will be standard form. Okay? All right, but I want to ask you this question though. What is the leading term? So the leading term, now be careful. Don't say the leading term is 8, right? Because your constant has exponent 0. Now when I say exponent 0, be careful. I don't mean 8 to the 0 power. What I mean is this. 8 means 8 times x to the 0. So your variable, because you can always write a constant as 8 times a variable raised to the 0 power. Your exponent is 0. That's what I mean by that, okay? So be careful. Yes, 8 is 8 to the first power. All right, but in terms of a polynomial term, your constant can always be written as 8 times x to the 0 power. All right, so your leading term is negative x. Now be careful, don't say x. It's important you keep your sign with it. So your leading term is negative x. What's the leading coefficient? Your leading coefficient is negative 1, because remember that means negative 1 times x. Okay, because negative x equals negative 1 times x. Okay? And then what is the degree? So the degree is, remember the degree is the exponent of the leading term. So here's your leading term. What's that exponent right here? 1. So degree is 1. Okay? All right, let's look at number 5. So number 5, we have this. We have so we have f of x equals 7. All right, so you graphed this before. Remember that graph is a horizontal line. Remember that? 1, 2, 3, 4, 5, 6, 7. So here's f of x equals 7. All right, so that's still a polynomial function. And you may say, well, how is that a polynomial function? It doesn't have a variable. Well, remember your definition. The definition of a polynomial function, if I go back to it, it's where we have all those terms. See, we have one or more terms. Doesn't have to be 2 or more. It can be 1 or more, okay? 1 or more terms where your exponents are non-negative. You may say, well, but this doesn't have an exponent. It doesn't have a variable, right? Well, remember what we just talked about. Y'all agree that f of x is 7 times x to the 0 power? All right? So don't you see this term right here? It would be one of these. Okay? In fact, it would be this constant, right? A sub 0. So this is your constant term here. So this function where we have this horizontal line is sometimes called a constant function. A constant function. And it's called a constant function because your y value is always 7. Your function value is always going to be 7. Well, we've talked about that before in previous lessons and in previous courses. Okay, so here's the question then that I need to ask you. What is the leading term? Well, there's only one term, right? It's 7. Leading term is 7. What is the leading coefficient? All right, well, the leading coefficient, if you look at this one, is 7, right? So the leading term and the leading coefficient are the same. So that's why sometimes we'll call this the constant coefficient. So even though we call this a constant term, sometimes it's called the constant coefficient. So the leading term is 7, the leading coefficient is 7, and the degree of f of x is, and that is where it was important important that you understand all those problems we did, all these problems we did, where we talked about the constant I can write as 5x to the 0 power. 7 is 7x to the 0 power. Negative 7 is negative 7x to the 0 power. And then we came to number 5, where we had this constant function. I can write as 7x to the 0 power, and now you can tell me the degree. The degree is the exponent of your leading term. Well, I only have one term, so that's the leading term, right? There's only one term. What's the exponent you see? 0. So the degree of f of x is 0. All right? And in fact, at some point you're going to understand that the degree of every constant function is 0. So the degree of every constant function is going to be 0, because this will always be a constant. So if this is 4.7, I can write this as 4.7x to the 0 power. So it's always going to be 0. Okay? All right, let's look at number 6. Number 6, suppose we had, number 6, let's suppose we had this one. Now, so we're going to have a little discussion with this one. So we have g of x equal 3x to the 5th plus 7x cubed, all divided by 5. Now, I want you to notice something. So if you look at number 3, the one, or number 4, it doesn't matter. But let's look at number 3. Do you agree? I'm gonna count the terms. Here's one term. Here's the second term. It's a constant term. Here's the third term. Here's the fourth term. So this has 4 terms, right? Okay. Now, do you see how this doesn't look like this, where these are written as separate terms? Here, it looks like you see a fraction, right? You see a fraction. Well, I want you to notice this. This is not in standard form. Okay, so standard form is where we have separate terms. So I need for you to write this in standard form. Write in standard form. So standard form would be this. You would say g of x equal 3/5 x to the 5th divided by 5. So 3/5 x to the 5th plus, and then 7/5 x cubed. That's standard form. Now here's why it was important. It was important you put in standard form for this reason. For this reason. What if I asked you to tell me what the leading term is? Some of you would have said this: the leading term is 3x to the 5th. That's not true. That is not true. The leading term is not 3x to the 5th. It's 3x to the 5th divided by what? 5. So the leading term is 3/5 x to the 5th. Okay, so the leading term is 3/5 x to the 5th. All right, so that was important. That was the reason why I wanted you to make sure you understand that this is not standard form. Standard form is this, where you have separate terms. Okay, so you had to write them as separate terms, where you had the coefficient in front of each term. All right, and then the leading coefficient. So the leading coefficient is 3/5. So the leading coefficient is not 3. The leading coefficient is 3/5. Okay? And then the degree of g of x, the degree of g of x is, you just look at your leading term, and what's the exponent you see? So the exponent is 5. So the degree of g of x equals 5. All right? Number 7. Now, in number 7, I want you to understand this now. So number 7. So number 7, we have this. We have k of x is equal to negative 4x to the 5th times x minus 2 times x plus 7. Now you may say, well, that doesn't look anything like a polynomial function. Okay. Now the reason I put this is because you will see this is a polynomial function, and you will see it written like this, and you will at some point write polynomial functions in factored form. See, these are factors. These are factors. Negative 4 times x to the 5th times x minus 2 times x plus 7. So remember, last semester when you factored polynomials, you wrote them as product of factors. Product of of whether it's a monomial or a binomial or a trinomial, whatever it may be. Okay? Now here's what I want to do though. I want you to understand that if I asked you what the leading term is, some of you would say this. That's not true. The leading term is not negative 4x to the fifth. Okay? That is a mistake some people will make. They see this and they think, well, that's the leading term. No, it's not. What I need for you to do is put it in standard form. So write this in standard form. So what's going to happen to put this in standard form is you're going to have to multiply this out. Now the way I would do this, remember multiplication is commutative. The order in which you multiply does not matter. So what I would do is I would multiply these two binomials first using the FOIL method. Okay, so x minus 2 times x plus 7 using FOIL. So x minus 2 times x plus 7 using FOIL, we'll go ahead and expand this, is going to be, remember FOIL, x times x is x squared, the outer is 7x, the inner is negative 2x, and the last is negative 14. Combined like terms, I get x squared plus 5x minus 14. So that's just this, okay? But that trinomial is being multiplied by this. All right, so we get this. So watch. So k of x equals negative 4x to the fifth times this trinomial. So x squared plus 5x minus 14. And then I distribute. And so k of x will equal, all right, negative 4x to the fifth times x to the second is negative 4x to the seventh. Negative 4x to the fifth times 5x is negative 20x to the sixth. So remember, you multiply like bases, you add exponents, remember that? And then negative 4 times a negative 14, so 14 times 4, if you don't note at once, and just use your calculator, 14 times 4 is 56, so plus 56, x to the fifth, okay? So this right here is standard form. And now can you tell me what the leading term is? The leading term is negative 4x to the seventh. So the leading term is negative 4x to the seventh. Your leading coefficient is negative 4. And then the degree of, and this was k of x, so the degree of k of x is, remember the degree is the exponent of the leading term or the largest exponent you see. So the degree is 7. Okay? All right, so those are examples of polynomial functions. So let me just quickly show you examples of functions that are not polynomial, and let's discuss why those would not be polynomial. All right, so here's the first one. So examples of not polynomial functions. Okay, so not polynomial functions. All right, so remember, in order for you a polynomial function, the exponents of every term, has to be non-negative integer. Okay, so let's do this one. So number one, g of x is equal to, let's say, negative 7x to the fifth plus 4x to the eighth minus 1/2 x squared plus, let's say, 7 x to the 2/3. All right, so this function is not polynomial. Why is it not polynomial? There's one reason why it's not polynomial. Remember, all you have to do is look at the exponent. Are all these exponent of the variables, non-negative integers? Nope. That's not an integer, right? 2/3 is not an integer. Okay, so this is not a polynomial function. The exponent on the variable And when I say the exponent of the variable, I'm talking about this one here. So the exponent of the variable is not an integer. Let me rephrase that. Is not a non-negative integer. Okay, so that's the reason. So the issue is this. So this is your issue right here. So remember, the issue is 7x to the 2/3. Okay, number two. Number two, let's suppose we had f of x is equal to negative 4 cube root of x, that's cube root of x, plus 7x squared plus 8x plus 5. Okay, what's the issue here? So that's not the issue because that exponent is 2, that's non-negative. That's not the issue because that exponent is 1, non-negative. That's a constant term, so we're okay with that. It's this right here. You got to remember, so recall the cube root of x means x to the 1/3 power. So there's your issue. So the issue is the term negative 4 cube root of x. That's your issue. All right. So the issue is that the exponent of this term of the variable is 1/3. So the exponent on the variable is 1/3, which is not a non-negative integer. Okay. All right, number 3. Suppose we had h of x is equal to 4 divided by x squared. So h of x equal 4 divided by x squared. Okay, so notice that first of all, when we did all these polynomials, and you can go back, and we're just going to look at maybe one of them that we did. So the first two, let's say. If you looked at all these polynomials, were any of the variables in the denominator? Your denominator here is 3. Negative x to the 4th divided by 3. Your denominator here is 1. Your denominator here is 1, and so on. So you didn't have any variables located in the denominator. But here you do. So when you see that, that should, in terms of polynomials, that should cause you some concern. So because a polynomial, we never did see any variables in the denominator. In fact, this is not a polynomial because if you recall from a previous course, I can write h of x as 4 times x to the negative 2nd power. All right, so that was something, in terms of negative exponents, was something you learned maybe 2 courses ago. So 4 over x to the 2nd power is 4x to the negative 2nd power. So what some students do is they think this is a polynomial because this exponent here, this exponent is non-negative. But where is it? Where is this variable? It's in the denominator, which means I can write it like this. So now you notice that the exponent is negative. So the issue is that the exponent is negative 2, which is non-negative, which is, let me rephrase that, which is not a non-negative integer. Okay? So non-negative, if you want to think about it, non-negative would be positive. So non-negative, think like this. Non-negative would be positive or 0. All right, positive or 0. So if you go back, notice that these are positive integers, right? And this is what if I rewrite this, what's that exponent right here? 0. Okay, so that's what we mean by non-negative, positive or 0. Now one more, and then we're going to move on. Let's look at this one. K of x equal, let's say we had 8x squared plus the absolute value of x. 8x squared plus the absolute value of x. The issue is this absolute value. The absolute value of x, it makes it not a polynomial function. All right, so remember, if you look at your definition says it's got to be of this form. It has to be it has to be some coefficient times x to a power plus some coefficient times x to a power plus some coefficient of x to a power. Notice I have 8 times x to a power plus, but that is not just x. That's the absolute value of x. Okay, so the issue is absolute value of x. Okay, so that's your issue. All right. So and then when we talk about something else later, we're going to look at this graph. You're going to see why it's not a polynomial function. Okay, so I gave you examples of polynomial functions, and I gave you examples of functions that were not polynomial functions. Now the next thing I want to do is talk about some names for some of these polynomial functions. There's some special names. There are special names. Okay, so listen carefully to this. So names for polynomial functions. Sometimes you'll see the directions stated like classify. So classifying polynomial functions. All right, so the first one is this. So the first one would be, and we talked about this earlier, so f of x equal, let's say, 6. So f of x equals 6. So remember, that's called a constant function. So that would be a constant function. So this polynomial function will be called a constant function. A constant function. Okay? So that's a constant function. It's constant because it's always 6. Y is always 6. That's why it's constant. Number 2, we have g of x equal 3x minus 2. That's a polynomial function. What's the degree of this polynomial function? The degree of this polynomial function is 1. So that's a linear function. Linear function. So I want you to remember that the degree here, the degree of a linear function is 1. Here, what's the degree of a constant function? Remember what we talked about, the degree of a constant function? That's 6x to the 0 power, so the degree is 0, right? So the degree of a constant function is 0, the degree of a linear function is 1. And you graph linear functions, you graph constant functions. Also what you did was you graphed, and the next one's this. Let's say we had x squared minus 3x plus 5. That's a quadratic function. Quadratic function. So this polynomial function has a name. It's called a quadratic function. And you graph quadratic functions in a previous lesson. The degree is 2. So the degree of a quadratic function is 2. Number 4, let's say we had f of x equal 5x cubed minus 7x plus 6. All right, what's the degree of this polynomial function? The degree is 3. All right, so a polynomial function with degree 3 is called cubic. So that's a cubic function, a cubic polynomial function. So a cubic polynomial function has degree 3. 5, h of x equal 6x to the 4th minus 3x squared plus 7x, let's say. What is the degree of this polynomial function? The degree is 4. So that's called quartic. Q-U-A-R-T-I-C. Q-U-A-R-T-I-C. Quartic. The degree is 4. Those are the special names. All the other polynomial functions, so I'm going to put a little separation here. Number 6, let's say we had f of x equal 6x to the 5th minus 4x cubed plus 3. The degree is 5. That doesn't have a special name. We don't have a special name for that. So any polynomial function that's not one of these, we say this. We call it, so we say this is a polynomial function, and we call it degree 5. All right. So the degree is 5. We just say it's a degree 5 function. It's a function with degree 7 or a function with degree 10, whatever it may be. But those are your special names. Okay, so constant function degree 0, linear function degree 1, quadratic function degree 2, cubic function degree 3, quartic degree 4, and we don't have any names for the others. So if you were asked what's the name of this function, you would just say it's a polynomial function with degree, in this case, 5. Okay? All right, so that's classifying polynomial functions. So we looked at classifying polynomial functions. We looked at identifying whether a function was polynomial or not, and we know how to find the degree. Okay. We looked at why a function is not a polynomial function. That was this one right here. Right. That was these right here. Not polynomial functions. And in terms of identifying characteristics of polynomial functions, so number 2, in terms of identifying characteristics, that was just talking about what the leading term is, what the leading coefficient is. Now later on we'll look at some more characteristics, but for this part, for part 1, that's all I wanted to talk about. So the characteristics were what's the leading term, what's the leading coefficient, what's the degree. Okay, there are some other characteristics we're going to talk about, but that's the only ones in part 1 for right now. Now, before we end this lesson, there's one part of the objective that we hadn't talked about that I really need to mention since it's listed as one of our objectives for part 1, and that's this. So let me go ahead and find the objectives again real quick. And it's right in front of me. It's this one right here. So we know if a function is given, if the equation is given, we know whether or not it's a polynomial function. But let's talk about the graph. All right, real quick, let's just look at some graphs and let's see what polynomial functions look like. So we know that x squared, we know what x cubed looks like, we know what a quadratic function looks like. So when we get to the other parts, you're going to understand the graphs a little bit better. For right now, though, for part one, what I want you to understand is this. Polynomial functions have smooth graphs. They are continuous. Okay, they are continuous, so they have smooth graphs. They are continuous, so there are no breaks in the graph. There are no sharp points, sharp turns. There are no sharp turns, like the absolute value. Remember we said earlier the absolute value function is not polynomial, is not a polynomial function. Because if you look at the graph of of the absolute value function, you have this sharp turn. So it's kind of like when you go from left to right, you go here, and then all of a sudden you make a sharp turn and you go back up. So you have this sharp turn right here. So polynomial functions look like this. Okay, so look carefully. So they look like this. So you have smooth, continuous. Look at my pencil point. Nowhere did I remove the marking, the point. Notice it's smooth, and then all of a sudden it goes back up like this. All right. So you have and we graph things like this. This would be more quadratic. Okay. You could have something that looks like this. Watch. So remember, smooth and continuous. Okay. Smooth, continuous. Smooth, continuous. See how it looks? So remember in one of our topics on functions, we talked about increasing, decreasing. Okay, so notice it's smooth. So where it turns, it's smooth. Where this term turns, it's sharp. That's a sharp turn. That's a smooth turn right here. That's a smooth turn. Okay, smooth turn, and it's continuous. One of the things that you graphed previously was a piecewise function. So I'm going to ask you, this is not, well, I'm going to tell you, this is not a polynomial function. So this is not a polynomial function. And you graph things like this. It's one of the previous lessons. So you have something that say looks like this. Okay? And then let's say this one did this. Okay, so that's not a polynomial function because watch. See how when we talked about this, we talked about these, as we went from left to right, we noticed this was continuous. Continuous meaning no breaks. Continuous and smooth. Notice the turn. The turn is a smooth turn. Continuous turn is a smooth turn. Turn right here is a smooth turn. So these are smooth turns right here. Okay? This is not a polynomial function. For one thing, you have a break. You have a break. It's not continuous. Okay, so watch. I go along here, then all of a sudden I have to jump. See, I made a jump. I made a jump to get to the next part of the graph. Okay, so that's not a polynomial function. That's not the graph of a polynomial function. All right, now, so these are polynomial functions. So these are polynomial functions. So these are polynomial functions, smooth and continuous. This is not a polynomial function because that's sharp turn, absolute value. This is not a polynomial function because there's a break. It's not continuous. I have to make a jump. Okay? So linear functions are polynomial functions. Also keep that in mind. So linear functions are polynomial functions. So even though it's not a curve, so to speak, like this, like see this little turning points right here, this turning points, it's still a function, it's still a polynomial function because of the definition, because of this definition here. So here with those examples, see a constant function and a linear function. And by the way, a constant function is also a linear function. We just call it a constant function because it has this form. All right, so that's why it makes it a polynomial function. Make sure you understand that this is still considered a linear function, although we call it a constant function. Okay. All right. So I think that should help you with part one in terms of graphs. Just know what that a polynomial function is continuous and smooth. The turns are smooth. That's important to understand. The turns are smooth. It's like going in a curve. This, remember when you make a 90-degree turn, let's say that's hard to do, right? So that's a sharp turn. That's not a polynomial function. Even though it's continuous, even though, you see, this is continuous, right? Notice this is continuous, but we have a sharp turn. Okay, so that's important. This is continuous and our terms are smooth. The issue here is that I have this break. So I'm continuing up to this point, but then I have to jump to get to that part. Okay? All right, so that should help you for the part one. And so that takes care of part one.